So we're going to move right into our next session, which is going to be moderated by Joan Rose, and it's on planning for sustainable water supplies and water resources. Joan, thank you for being here. She's with Michigan State University, and she is a former Clarke Prize recipient. Joan?
Thank you. Yeah. All right. We'll get right into it with our first presentation. It's a pleasure to be here as always, and I'm looking forward to all the talks. I think we got started off this morning with great perspective, thinking about the world and global issues. So we're going to have some local sessions, and then we're going to go back to the issue of global, talking about water and climate. So we're going to be talking, this session is on planning for sustainable water supplies and water resources. Our first presenter is Roy Herndon. He's with the Orange County Water District. He's going to be talking about Sustainable Groundwater Management Act and the Orange County Groundwater Basin. You probably know Orange County's been a leader, not only in California, but globally. And probably with this recent drought, they've been getting a lot of attention and accolades for their look into the future. Roy is the chief hydrologist at Orange County Water District. He's actually a Wildcat, University of Arizona Wildcat, and also got his BA from Colorado College. He's a professional geologist and certified hydrogeologist. And for the last 20 years, he's directed the hydrogeology department and looked at groundwater flow modeling, performance evaluation, and improvement of 2 seawater intrusion barriers and operation of a comprehensive water resources data management system. So he's really done a lot. He's really been one of the leaders there, making things happen, linking the science, I think, with the management. Roy, thank you.
Well, thank you, Joan. It's hard to believe it was about almost 20 years ago that I first was introduced to you and other panel members that the district used and hired for our Santa Ana River monitoring program, or water quality and health study, I think was what we called it. So it's a pleasure to be introduced by you, and I thank Jeff and NWRI for inviting me to give a presentation to you folks today. So we are going from the developed world to the developing world to the developed world, where we are really, really fortunate to deal with conflicts through public forums, media, campaigns, lobbyists, and attorneys. But that, I would prefer that any day over the other kind of conflicts resolution. So anyway, so I will talk about some of the issues that the state is facing and how Orange County Water District is dealing with it. And so we talk about sustainability. It's getting to be an overused word, I'm afraid. We hear it in everything. It really wasn't in the jargon when I was at Arizona about 30 years ago now. It was, we just call it hydrologic balance. You pumped the groundwater basin and you made sure recharge kept up with pumping, and that was sustainability, but we just didn't call it that. Of course, there's a lot more than just keeping a groundwater basin in balance. There are quality issues and so on that I'll talk about. But anyway, it's not something new to me as a hydrogeologist about being sustainable, but I guess certainly it is to the community and other areas. So let me talk about the Sustainable Groundwater Management Act. Here in California, this was a groundbreaking legislation that was signed into law last year by Governor Brown. It was many years in the making, and it's going to change over time how California deals with its water supply, not just groundwater, but overall water supply. It's so much very, very linked with surface water management, and so it's really an overall water supply legislation that was passed. The state has over 500 groundwater basins. And 127 of those have been designated as high and medium priority basins. That basically means that these are basins that are heavily populated, or heavily used for agricultural purposes. So the California Department of Water Resources went through a ranking process and came up with of the 500 basins, 127 of them are high and medium priority basins, and those are the basins that had to comply with the SGMA, Sustainable Groundwater Management Act. It's such a mouthful, I'll say SGMA if I can. So one of those basins, of course, is the basin that we're right on the edge of here on the coast. The Orange County Groundwater Basin was designated as a medium priority basin, given our large population that depends largely on the basin for water supply. So what does the Act require? Essentially, that these basins develop a sustainable groundwater sustainability agency governance structure. So if there is not an agency like Orange County Water District or an adjudication, basically a court decision that allocated the water rights, these groundwater basins need to establish a governance structure to oversee and manage that groundwater basin. And I'll talk a little bit more about that in a little bit. The Act also allows for boundary adjustments. The Department of Water Resources established boundaries for these 500 basins or 127 basins, and they are allowing for proposals to modify those boundaries if they don't make sense, either for physical reasons or political reasons. If the proponent can demonstrate and make a good case, compelling case, why a basin boundary should change, either through subdivision, which the state is very much against doing. They don't want to see any more granularization than we already have with these basins, or consolidation, which could make a lot of sense in some places. So that is also one of the early steps in the process, is to review the basin boundaries and see if there should be some adjustments. Those need to be done by 2017, so that's not very much time for all the agencies to review their boundaries and decide if they should be changed, and then to put a case together to convince DWR that it makes sense. These groundwater sustainability agencies need to be formed by 2020 or 2022. I know that's a minor distinction depending on whether you happen to be one of the lucky 15 or 20 basins that have gotten the extra designation as being in a state of critical overdraft. And so of those 127 basins, about 10% of them or a little more have that extra designation, and they have the 2020 deadline as opposed to all the other basins. It's 2022 to establish groundwater sustainability agencies and, more importantly, the groundwater sustainability plans. And I'll talk about what those plans are for and what the contents of those are in a little bit. So deadlines are coming. That sounds a ways off, but here we are almost in 2016 in another couple of months. So 2020 and 2022 are going to be here very soon. And there's a lot of work to be done between now and then for a lot of basins. The ultimate goal is to achieve sustainability, and I'll define that here in a little bit. And that is way down the road. That these plans have to be in place by 2020 or 2022, but the agencies have 20 years to get to a point where they are in a sustainable state under the definition of the Act and in the eyes of the Department of Water Resources. If they aren't, if they don't achieve that state, or if they don't comply with the Act, then the state comes in and does its own groundwater management or its own groundwater sustainability plan for that area. So one of the main foundations of the Act was local governance. The state did not want to have a top-down regulatory structure for groundwater management. They want the local agencies, largely based on input from the local agencies and the counties and local jurisdictions, they want them to manage their own situation as much as they can, but under the certain requirements of the Act. But if they don't do that, then the law provides that the state will come in and manage the basins for them. And that's kind of the big hammer that the state has if the agencies don't comply. So this act was a long time in the making. The forces that were driving the need for sustainable management, groundwater management in the state were going on for years. We were the only state in the West that did not have any regulation of groundwater statewide. We didn't have any laws in place to deal with groundwater locally, other than individual basins that maybe had gone through an adjudication, a water rights allocation process, or the almost unique situation that Orange County Water District is in as far as having its own act, its own state legislation that gave us the statutory authority to do what we do as an agency. We're almost the only one like us. It's amazing that this wasn't done in other areas, but the history is fascinating. I don't have time to talk about that today, but there was a lack of groundwater pumping reporting or monitoring. There was a lack of groundwater level monitoring, and therefore the state knew there were problems, but they didn't have a good handle on what was causing them, at least in a very global macro sense. And so the lack of data collection, the lack of reporting of production were also huge drivers for the need to change things and establish some kind of regulatory framework for the state. Probably the largest driver for the act to be put in place last year was what was happening in the Central Valley. That's the ground zero of overpumping in the basin, in the state, and I'll talk a little bit about some of the impacts that they're seeing. You've probably read a lot about it in the paper. But if it weren't for the Central Valley situation, if that didn't exist, I don't think there would have been enough political impetus to have that legislation passed. There were many attempts at doing some kind of regulation of groundwater before last year that failed, but I think things got so bad in the Central Valley, certainly exacerbated by the drought and recent cutbacks in the Delta, that just kind of put us over the top, and the state said we have to do something. So in some sense, the rest of the state areas are going to be regulated under this new law, largely, I think, due to what happened in Central Valley. There are areas of subsidence in the Central Valley, in particular. Also, seawater intrusion in some areas were also drivers. And as I mentioned, the drought has just really pushed things into high gear as far as what needed to be done. So this is a graph just to focus on the Central Valley just for a minute. We see here a chart that shows the depletion of groundwater storage. This chart goes back to about 1962, so a little over 50 years of data. And in particular, since 1984, we see about 60 million acre feet of groundwater storage depletion in the Central Valley as estimated by USGS and JPL. So this is a tremendous amount of water storage that's gone, and it was enough that it could be measured by satellites. They could detect the change in gravity. These are the GRACE satellites that Jay Familietti at UCI and JPL has been in the media quite a bit on. And so it's a huge amount of water. It equates to about the volume, a little more than the volume of Lakes Mead and Powell combined. It also happens to be about the same volume of water of the Orange County Groundwater Basin if we could somehow magically drain every last drop out of the aquifer. It's about 60 million acre feet. Of course, that's impossible, but that happens to be the same estimated volume. What's particularly interesting is that storage depletion. I have that map there on the Central Valley. The purple area in the south is the southern part of it, sometimes known as the San Joaquin Valley or San Joaquin Basin. That is where most of that storage depletion occurred. So it's not the entire Central Valley where we've seen that kind of drawdown. It's really the southernmost part of it. So that is the ground zero, if you will. So I mentioned, aside from the storage depletion, essentially way more pumping than is being recharged in that area. That has then caused a significant amount of ground subsidence, land subsidence in that area, 1 foot per year in some places. In fact, recently we've heard there have been places where they measured it as much as 2 feet per year of subsidence, which is causing significant problems with drainage, aqueducts and things, highways and whatnot. I mean, if that were happening in an urbanized area, we would have billions of dollars of damage potentially. So that's a real problem. When you pump too much water out, you do end up with subsidence in many cases. Depends on the geology, of course. So what does the SGMA require? Basically, the Groundwater Sustainability Plan is the core piece of documentation that will determine how a local area will manage its basin. And it essentially involves a set of measures that will allow that basin to be operated sustainably. And what does the state mean by that? The Act says sustainable means that there won't be undesirable results during the course of operating under this sustainability plan. So what are these undesirable results? Well, I covered some of them. Chronic lowering of groundwater levels, just chronic reduction in storage, showing that you're essentially not sustainable. You're just pumping more and more out than what you're recharging, and that's clearly not in keeping with the goals of the Act. Seawater intrusion, you might have the other two things worked out where you're not putting you're not taking out any more water than you're recharging it, but you're doing it in such a way that part of your basin is being degraded by seawater intrusion. You can actually have both of those. You can pump too much in one place. In the net, you're fine, but locally you're causing major problems such as seawater intrusion. That's an undesirable result that the state won't accept. Degraded water quality, another problem that's becoming an issue in the Central Valley and other areas where you're pulling in poor quality water either from above or from below due to unbalanced pumping. Land subsidence I talked about, and very importantly, the Act includes impacts to surface water. If you're over pumping a groundwater basin or you're pumping a basin in such a way that you're depleting surface water flows and causing significant impacts such as environmental impacts, that becomes an undesirable result. That is a huge issue for local groundwater agencies to begin to deal with. It's been obvious, but now it's in law that says that these agencies have to address that. So what goes into a plan? Those are the objectives. Don't have undesirable results. Well, those are all great goals to have, but how do you accomplish that? Well, you start with the basics. You start with defining your basin boundaries, defining the hydrogeology, the aquifer systems, the interconnection of your aquifers, your sources of recharge, where your pumping is occurring. You know, all the basic pieces that go into understanding and characterizing your groundwater basin. Water levels, water quality. Do you have areas of nitrate? Do you have seawater intrusion? Do you have land subsidence? Is your basin susceptible to those kinds of things? And to document that, and then essentially looking at your projections of future demands, future water supplies, not just historical, but where is your basin heading? Are you in a fully developed area like Orange County where we essentially don't have any agriculture left, but it's really a question of future water demand, largely driven by population growth and continued densification. That's kind of what we're looking at. So these are all pieces that go into the physical understanding of the basin and looking forward. The key, though, is what are your objectives? If you're not currently in a state of sustainability where you're not currently experiencing any undesirable effects, and you've got things pretty much under control, then you're in great shape because you just have to show that going forward, you're going to be able to stay there despite future pressures of increased water demand, population growth, et cetera, that you think you're going to be able to stay within that nice sweet spot of no undesirable results. On the other hand, if you do have any of those problems currently occurring or multiple of those, then you have to show how you're going to bring those back and to essentially eliminate those over time. Now you have 20 years to do it, or actually more than that. You've got till 2020 to develop a plan, and you have another 20 years after that to get to the point of sustainability. But that sounds great, that gives you plenty of time, but the state needs to show in the plan how you're going to reach that glide path in 20 years. They don't want to just wait 20 years and see if you're there. They want you to show along the way how you're going to be there and have 5-year milestones to show that you're actually achieving it. So what is the district doing? We look at what the rest of the state, or certain parts of the state, particularly the agriculturally dominated parts of the state, what they're facing as far as the requirements of the SGMA go, and it's a daunting challenge. And I don't know exactly how they're going to get there personally, but we're very fortunate that our longstanding policies as a groundwater management agency have really mirrored what the Act has called for the rest of the state. So we're looking at this going, well, this is mostly what we do already. And so it's just fortunate. And we're not bragging, it's just that's been our mission all along. This is what we have to do, and it's been outlined for years. So we're just following along what makes sense, and we've been fortunate to mostly accomplish that. So for those who are coming from out of state, don't know us very well, I'll do the quick, who are we, what do we, who is Orange County Water District? Here we are, about a 300 square mile area, Groundwater Basin, northern part of Orange County. We see the LA County line is nothing but a political boundary. The aquifer system continues to the northwest into LA County. They have their own groundwater basin there. And the red dots represent production wells. These are the 200 or so large capacity wells pumping 2,000-3,000 gallons a minute each that provide the residents of northern Orange County 70% of their water demand. The other 30% generally comes in from imported water coming in from Northern California or the Colorado River. That's the other main component of the water supply. So 2/3 of the water comes from underground, and I talk to people all the time out in the community, and they can't believe it. They all think their water comes from the aqueducts, because that's just been ingrained in their mind that that's where the water comes from, and they don't realize that you pump it out of the ground. So anyway, that's you can see the wells are pretty well distributed around the basin, and each one of those nowadays would cost about $4 or $5 million to replace. And the benefit by pumping groundwater versus buying imported water, which is more than twice the cost, is about $150 million a year economic benefit of having a groundwater basin, having a groundwater supply, than paying upwards of $1,000 an acre foot for imported water. So 300,000 acre feet a year of groundwater times that delta gets you around $150 million savings than if we were, say, San Diego or someone that's almost 100% dependent on non-groundwater for their water supply. What's particularly interesting for OCWD is that, but not for us, I guess, but for the state, is that we actually monitor how much pumping. It's metered. All these wells have meters on them, so we know exactly how much groundwater is pumped out of the basin. This is blasphemy in other parts of the state. This is something that the farmers and others have fought for decades. And even in the legislation, it was such a hot button issue that the state doesn't say you have to have a meter on your well. It just says you have to have a means of estimating or quantifying the amount of groundwater production from your groundwater basin, but they don't explicitly say through a meter. Now this happens to be a pretty easy way to go, but if we want to use satellites to do it, that's fine. But I think we could do it less expensively by just putting some meters on the wells. But anyway, it's not rocket science here. But anyway, we have a pretty good handle on that. In very simple terms, we have a nice deep groundwater basin, very transmissive, very permeable. We have 3 major aquifer systems, shallow, principal, and deep. Most of the pumping occurs within that principal zone, say 300 feet down to 1,500 feet. That's where most of the groundwater wells are perforated and pump their water from, and that works out great. We do have some areas where we have seawater intrusion. We are dealing with that. What's useful with this graph, this is groundwater production since the 1950s. And it shows how we've been able to utilize the groundwater basin increasingly over the years. We've more than doubled production since the 50s, yet sustainably. We're not depleting the aquifer. We've been able to pump more because we've been able to recharge more and not cause seawater intrusion, or at least control seawater intrusion. And so this is the key. We've been able to get the most out of this basin without causing undesirable results. So our recharge facilities, we have 1,000 acres of spreading basins up in the Anaheim area. That's where the brunt of the water gets recharged, but we also have 2 seawater barriers that represent about 10% of the total recharge in the basin. They are seawater barriers, but they're also recharge sources for the basin. People don't realize that that water is mostly going into the basin and not going out to the ocean. Our major source of supply historically has been the Santa Ana River, where we divert storm flows and base flows. The base flows largely are made up of wastewater from upstream, treated wastewater from upstream agencies, but that water supply is diminishing. The upstream agencies think of us as the ocean. If it gets to us, they've lost it. And so they're doing everything they can to store and conserve that water and not let it flow to Orange County. So it used to be more than half our supply. Now it's down to 1/3. And we see a graph here. The red line are the wastewater discharges upstream of us. We can see how it peaked about in 2004 and has reduced, and the base flow follows that very closely. So we've lost 80 to 90,000 acre feet of free water. And so that's water we didn't pay anything for, but it's their right to conserve the majority of that water. So fortunately, many of you have heard about GWRS, Groundwater Replenishment System, is more than made up for that reduction in base flow. Of course, GWRS isn't free, so we are essentially paying for this largely. But very fortunately, we have that supply, and it's much higher quality than the base flow of the Santa Ana River. And we see the other parts of the pie chart, the other sources of water to the groundwater basin. And so this is a really, I think, helpful graph that shows since the 60s how our basin has gone through various cycles of storage, emptying and filling. But you don't see a downward trend here. This is essentially, it's going up and down, but within a defined operating range. We're probably one of the only basins in the state that even knows how much storage they have to any degree of detail and has established an operating range. For us, it's about 500,000 acre feet from full is as much as we want to pump. And we've stayed within that range for 40 years. We have a very extensive network of monitoring wells that help us define how much water we have and what the quality is. It allows us to calculate changes in water levels each year, which defines how much change in storage we've had each year. So we know that's how we measure how much water is coming in and out. Besides measuring how much we pump and measuring how much we recharge, we actually physically measure the water level changes throughout the basin. And so we have 2 checks. We have our basic accounting in and out budget, and then we have the physical change in water level method, and the 2 match up pretty nicely. We have groundwater flow models that help us test out future scenarios of pumping and recharge and see how the basin might respond to that. And we also have water quality improvement programs. We store water behind Prado Dam upstream in cooperation with Army Corps of Engineers. We have wetlands that treat the water, that remove nitrate coming down the river before we recharge it. And we also have undertaken a number of industrial contamination investigation and cleanup projects to deal with, I'll call them legacy contamination from our post-World War II industrial era. Like many areas, urban areas, we have things like chlorinated solvents that we're dealing with. So we really have a pretty well-rounded groundwater management program at the district that we're very proud of, and this is something that we're going to start seeing throughout the rest of the state. So we do have a new bar that's been raised for the rest of the state. For us, we're already hopping over that bar, but it will be fascinating for me to see how the rest of the state responds and deals with this. It's going to be a huge technical challenge, economic challenge, and even more so institutional challenge to develop governance that the rest of the state can deal with and trust. They don't want to put their faith in someone, but they say it's local, but they're still going to have to put their faith and their trust in an agency that's really going to start dictating and helping to determine how much pumping and whatnot a basin can sustain. It will require a large investment in data collection and analysis, because without that, you're flying blind. And so that's something that we're likely to see. Anyway, I think that concludes what I had to present, but I'm ready for the next speaker or questions. I don't know how you want to do it.
We'll take a few questions.
Okay. Thank you.
All right, the paper's open for questions. Roy, I think that you brought up 3 issues, and maybe you can just talk about what you think, based on your lessons learned, you can give to others, not just in California, but I think globally, because groundwater overdraft globally is a big issue. And I think one was agriculture, areas where there's a lot of agricultural use. The other was just the definition. So the definition right now means we have to think about restoration, because most of the basins aren't going to meet that definition of no harm, at least in one of those criteria. And the third is monitoring.
Yeah, it's a daunting challenge. The agriculture in California accounts for 80% of all the water use in California, at least man's water use, not the environment. 80% is agriculture. So with that kind of a deficit, 2 million acre feet a year deficit on average, I don't see any other way. The farmers are certainly becoming more efficient with their water use on a per acre basis, but at some point, I think there isn't enough water to fill up that deficit without some reduction in usage. I think that's inevitable.
Okay, let's see if we have some other comments.
Hi, Clemencid from Caltech. I was just wondering, you were mentioning that you were saving $150 million a year from not buying imported water. Does that include the cost to treat the wastewater up to potable level or not?
That is essentially the melded cost of groundwater, or the difference between the melded cost of groundwater that includes all the fees that we charge, that include recycling the water, recharging the water, preventing seawater intrusion. That all adds up. The cost of drilling the well, the cost of pumping the groundwater out of the ground, all that melds together to about $500 an acre foot. You compare that to $1,000 an acre foot of imported water. That's the calculation.
Okay, thank you.
We see any other hands? Okay, I'll ask the last question then. You mentioned satellite, like remote sensing or something like that. I mean, I think that we may have to go to that type of technology, because we're not going to get meters, I don't think, on every well. And how far away are we from using that technology, you think, efficiently?
I can tell you what Jay Famiglietti, this is Professor Famiglietti at JPL, and I think he's still at UCI, but he's not. Okay, JPL, Jet Propulsion Laboratory. He has told me that his method, using the gray satellites, the gravimetric method, is really only good on a massive basin scale, like the magnitude of Central Valley, and it really isn't applicable or able to resolve local basins. So there are other means. There are estimates of water use by crop and by electricity. So there are non-satellite methods and non-meter methods that can be used to get a reasonable estimate.
At the resolution we need it.
At the resolution that's needed,
Okay.
yes.
All right. Very good. Let's thank Roy one more time.